this presentation we will see what is meant by coverage in System Verilog. I am going to cover the concept on coverage, that is what is meant by coverage and what are the different types of coverage we are using in System Verilog. So let us first see what is meant by coverage. In System Verilog, coverage is especially one of the metric which is used in order to measure how thoroughly design has been tested. It also helps us to ensure that all parts of our design have been exercised by the test bench, identifying the areas that may need more testing. Coverage is especially, we know it is very crucial in the verification process in order to achieve high confidence in the design's correctness. So this is what coverage in System Verilog actually mean. Next we will discuss what are the different types of coverage in System Verilog. So main different types of coverage what we have in System Verilog is in terms of code coverage, then functional coverage, bug rate as well as assertion coverage. So we will discuss these one by one. So in terms of code coverage, what is the testing process being done in terms of code. So how thoroughly a design has been tested in terms of its coding. So that is nothing but code coverage. So this code coverage is again further divided into different types of coverages. One is called as statement coverage. Next we call it in terms of branch coverage. Third one is condition coverage. Next is toggle coverage, and last it is FSM coverage. So what are these different types of coverages under the category of code? So first and foremost thing what we have in code coverage is listed in terms of statement coverage. So this statement coverage is nothing but it is going to measure whether each line of a code has been executed or not. So that measurement we call it as statement coverage. And second type is nothing but called as branch coverage, which is going to check if each branch of control structure, like it may be in terms of if statement for example, has been taken into consideration in the coverage or not. Third one is condition coverage, which is going to ensure that each boolean sub expression in a particular decision has been evaluated to both the values in terms of true as well as false, or I can call it in terms of logical 1 as well as logical 0 state respectively. Next is a toggle type of coverage, which is going to verify that each bit of a signal has toggled between logical 0 and logical 1. FSM, so all of you know FSM stands for finite state machine. So FSM type of coverage is going to ensure that all states as well as transition in an FSM, that is finite state machine, have been exercised, have been covered or not. So these are the different types of coverage in code. So statement, branch, condition, toggle, FSM. So according to our requirement, which type of coverage is essential, that will be executed during the particular process. Next broad category in terms of coverage type is functional based, that is functional coverage. So we know what are cover groups as well as cover points. So user defined constructs that is going to specify what aspects of the design should be covered are called as the cover groups, that is cover points are specific points of interest, and cover groups are collection of different cover points. We also know what is meant by cross coverage, which is going to measure the coverage of combination of different cover points. So say C1 as well as C2, if they are two different cover points, then I can call the cross coverage in terms of C1 cross C2, which is going to measure the coverage of a set of combination of different cover points C1 and C2. This cross coverage is going to ensure that all possible scenarios of our interest are tested or not. Next, we will be seeing what is meant by bug rate in the types of coverage. So, bug rate is a type of coverage what we have, which is going to refer to the frequency at which bugs, or I can call it as a defect, are found in a particular design during the verification process. It is a very important metric in assessing the quality as well as stability. The quality as well as the stability of the design is being assessed by using this particular metric called as a bug rate. A high bug rate means it indicates that the design has many issues. So, high bug rate means so many issues are there in that particular design process that has to be addressed or that needs to be addressed, while low bug rate suggests that the design is more stable and reliable. So, this is how the metric bug rate is going to summarize regarding the design, whether there are any issues present in our design which has to be addressed, or is it okay with the low rate of bug, whether my design is stable, whether my design is reliable or not. So, that will be decided, that will be addressed by knowing the value of the bug rate. And the last type of coverage what we have is an assertion type of coverage. So, this assertion type of coverage is going to measure of how well the assertions in a particular design have been exercised during the simulation process. Usually, these assertions are used in order to specify expected behavior as well as constraints in a particular design, and it is going to help us to verify that these expectations are being met or not. Assertions in the System Verilog will be written using the System Verilog assertion, which we have already seen in our previous module, System Verilog assertion language. These can be checked dynamically during the simulation process in order to ensure that whatever the functionality of the design has been expected, it is met or not. If an assertion fails, it indicates a potential bug is present in a design which has to be addressed. So, these are the different types of coverages what we have in System Verilog. Let us know in detail with the help of example. So, functional coverage we have seen in our previous slide, wherein we discussed regarding the cover group as well as the cover points as well as the cross coverage. So, as I already told you, the cover points are the specific points of interest in our design, and the cover groups will be the collection set of collection of our cover points what we have in our design. Also, we have seen what is meant by cross coverage, which is nothing but a measure of coverage of different combinations or combinations of different cover points in our design. So, this is one of the code which is taken as an example to explain the functional coverage. So, in this example you can see there are different keywords used over here. One is called as cover point mode, another one is called as a cover point key. So, what is this mode and key? This mode and key are called as the variables for which the coverage is to be measured. And as we already discussed in our previous presentations, the CG is a cover group that is going to sample on the positive edge of a clock pulse. So, always at pause edge of a clock signal you might have studied in normal Verilog. So, in System Verilog, in the cover group I am having the name as CG at pause edge of a clock, which is nothing but CG is a cover group that is going to sample on positive edge of the clock pulse. Here we have mode as well as key. So, this mode and key are defined as cross points with bins for all the possible values. So, you have mode as well as key. So, the possible values are given. For mode it is from 0 to 15, for key it is from 0 to 3. The cross mode key statement measures the cross coverage of mode as well as key. The cross mode key what statement you can see here. Mode and key are the cross points, whereas cross mode comma key what you can see in the statement over here, it is going to measure the cross coverage of mode as well as key cross points. So, to tell you in brief, to summarize what is this functional coverage is, it is going to measure how much of the design's functionality has been exercised using user defined cross groups as well as cover points, cover groups as well as cover points. This is cover point. So, these coverage metrics that is in terms of functional coverage what you have seen over here will help us to ensure that the design has been thoroughly tested, identifying any gaps which are present during the verification process. So, this is a program example of assertion type of coverage. So, in this program example you can find a property block. So, here you have a property block which is going to define a property P underscore valid underscore data. This is going to check if data is not equal to 0 within say 1 to 5 clock cycles after valid and ready are high. The assert statement what you can find over here, it is going to check this property. It is going to check the property during the simulation process, and it is going to report any error if the property is violated. Whereas the last one, that is the cover statement what you can find over here, it is going to collect the coverage data for this property, incrementing a counter each time the property is true. So, this is regarding the assertion type of coverage, which is going to provide insight into which parts of the design's intended behavior have been tested and which has not been tested. It is going to help in the identification of areas that need more testing and can highlight scenarios that have been missed in the test plan. So, in this presentation we have seen what is meant by coverage and what are the different types of coverage used in System Verilog. Hope you understood this concept. Thank you for listening.